Okay, today we're ready to start chapter 3. So before we get into chapter 3, let's go over some basic terms and concepts that are going to be really critical for this chapter. So first thing let's talk about is going to be what a relationship is, function, domain, range, independent variable, and dependent variable. So let's kind of tackle those first. A function is going to be anything that represents basically a direct to a independent. So let's say I have y equals 3x plus 2. So this is just one example of a function, or y equals 2, or x equals 3, or you can say that you have 3x minus 2y equals 6. Anything where it's really one-to-one. A way to test to see if something is a function is called the vertical line test. And with that, you're going to actually need a picture or a diagram. So let's say that I have a graph like this. Okay, so if I have a graph like this, it keeps going up and down, up and down, up and down, and I draw a line through it. Now the line, if I draw a line through this and it only crosses the value for x once, then yes, it is a function. So this is an example of a function. Now it doesn't look like something you're used to working with, but it is still a function. If you have a parabola, so a parabola opens down or it opens up. If you do the vertical line test for either one of these, you're going to notice it crosses it only once. So the vertical line test is basically this here. You take an image and you check. These are all yeses. Now, an example of a no was put down below here. So this is not an example of a function. Okay, let me scoot that up so you can read it. So it's not an example of a function. And that would look something like this. So if we had something that opened like this way or this way, if you drew a line through either one of those, it crosses it twice. So that's what makes it not a function. Another not a function that we're going to run into is a few of these. So remember, if you can cross it once, it's considered a function. If you cross it twice, it is not a function. All right, so just looking at some of these examples, this is probably the ones that you're going to run into the most, just checking to see, are you paying attention? So if you had zigzag lines like this on your graph, that would be a no also. Because if I drew a line straight down, it hits it multiple times, not just once. So keep in mind that a function is very specific. It is a graph in which if I draw a vertical line down, it only hits it once. So the definition is a graph represents a function when no vertical line passes through more than one point on the graph. All right, so that's what they're talking about here. So let's talk about some other specifics with this. So let's look at domain and range. All right, so now we're going to get into a little bit heavier topics here. You need to remember that domain values of x, okay, and range are values of y. So when I ask for domain and range, I'm asking for the values that x is going to cover or y is going to cover. Usually they're wrote as an inequality. Sometimes they are wrote as a set that you can do. An example would be like if I had a straight line like this, your domain and your range is going to be all real numbers. So if I had this example for my first one, this is going to be negative infinity to infinity for both domain and range. Here's my reasoning. The line is not stopping just at the end of the arrowheads. They're going to keep going on forever. All right, so that's going to keep going and going and going. However, if I have, let's say, a graph like this, where I start here and then go off this way. All right, and this is something that you're going to learn is called exponential growth. So just keep in mind that some of this stuff, it is a function, but it's a unique function of that. So keep that in mind as we go through this. So as we graph some of these, if you notice, the starting point is at the origin. So that means my domain, which I'm just going to call D, it starts at 0. So I'm going to put a hard shell there, meaning that's my starting point, and it's 0. My forever going on is going to be infinity because I'm going to be going, and that's a soft shell because there is no stopping point. Okay, that is not going to be a place where you stop. You just keep growing and growing and growing. Where 0, it is a hard defined, that's where I started. Now, the range is very similar to this, and here's why. Range also starts at 0 this time, and it is a hard shell starting point. Now, it's going to keep going up. May not grow fast. We don't know what all is going to happen with this graph, but we do know that it is going to keep going up. So if that's the case, we're going to call this infinity. Once again, it is also a solve. Now, domain and range very rarely are the same thing. And let me give you another example of that. So this right here is a closed set. It's a continuous, but it's still a closed set because I'm starting here and I'm ending here. So let me put a few marks on this. So let's say that this point over here is negative 3, 1, and this point over here is 2, 1. So if I keep going up, this right here where it crosses is at 3. So 0, 3 is where I cross. So when we're looking for domain and range, I have to kind of know a couple things. First, if it's going up like in an arch, you're going to call this a parabola. Then you are going to be looking for the highest point, which is the maximum point. In this case, it's just 3. It has stopping points here. So this isn't truly a quadratic because quadratics normally don't have stopping points. All right. So let's take and go back here. And if I asked for my domain, you are going to tell me it's a closed set starting at negative 3 and ending at 2. So that means that I start at 3 and I go to 2. That does not make an order pair. Negative 3, 2 is not an order pair. It is where I start and I finish for my extension across. Same thing with range. If we look at our range, it is a hard set. I started at, well, my y value is 1. We go up as high as 3. Hard set also because that does not go any further. So this has a hard set for domain and range. All right, so this is just a few terminologies going through. We will work more and more with domain and range as we continue this. You will see this a lot more in Algebra 2. We just kind of start growing here and getting you filled in on terminology before you get into the next level. Now, we said we were going to talk about independent and dependent, so let's flip over the page and talk independent and dependent. Okay, so an independent and I think I forgot a few letters here. So my independent, and it should be a D-E-N-T, is going to be something like this. An independent is always your x value. Here's the reason. When you have your equation, we call this our slope-intercept, y equals mx plus b. you are going to learn that this x is the driving force of the equation. The y is just the outcome. So you're going to learn this is called input and outcome. They also call it output, but I call it outcome because it's a result. So my dependent value is going to be y. So your dependent value is going to be y. We know this because once again, we put in an x, we get a y. So in our notes on page 62, you're going to see an image at the bottom. It says domain and range of a function. And what it's talking about is if I put a number in, it's going to give me a number coming out. The example they have here is y equals 3x. So what it's saying is no matter what you choose for x, you're going to get a y value. So when we go to start graphing these, you're going to hear me talk about tables. And the table basically is getting ordered pairs so that you can graph it. So if I tell you that this is the x and y, and I say, give me x's, so you can choose 0, 1, -1. They put in -2, and let's put in 2. As you notice, I don't really have them in order. I just kind of have them there. When you graph it, you will see the order. So if I put 0 in for x, 3 times 0 is 0. So that means I'm going through the origin. So this is what we call a direct variant. Direct means that wherever I get an x, I will get a y, and I'm going through the origin. If I ask for something direct, that means I'm going through the origin. Very important to understand. Indirect means that I have a y value that's going to shift me up or down. So there's some terminology there that you will start playing with as we go through. So if I put in 1, so y equals 3 times 1, that's going to give me 3. If this was y equals 3 times -1, that's going to give me -3. Y equals 3 times -2, that's going to give me -6. And y equals 3 times 2, that gives me 6. So let's say I want to graph this. So I have some graph paper here I'm going to put up on the overhead. So if I ask you to graph this, and I'll scoot this up a little bit, we have our table right there. So we have this here as being my graph. Hopefully you can see that I've made a table already. Graphing ordered pairs is something that you should have done last year or started last year. So let's just continue this. So remember that the origin is where the two axes cross here. So x's move left and right. If you go left from the origin, they are negative. If you go right from the origin, they are positive. If you're talking y's, y's go up and down. So if it's a positive y, it goes up. If it's a negative y, it goes down. So if you need to label your axes to help you, that's fine. Usually there's a number line attached to it so you can get the positive, negative part. So the first one's 0, 0. So I'm just going to put that there. The next one tells me to go right 1 because it's a positive x, and it tells me 3, which means I'm going to go up 3. So there's my next dot. The next one, it says go back to the origin. Now, if you notice, you're going to start back at the origin every time you graph an order pair. So from here, it tells me to go back 1, and I go down 3. So I'm going to be down here. Let me scoot this up. Now, the next two are going to be 2. So if I go back 2 from the origin, I'm going to go down 6. So I'm going to be right here. And if I go here, I go over 2, I'm going to go up 6. So now we have a very clear illustration of what my line looks like. And like I said before, it's a straight line, so it's going to go on forever and ever and ever. So that means that my domain is going to be negative infinity to infinity, and my range will be the same, negative infinity to infinity. So if I ask you to tell me something about the domain and the range, you can tell me it is all real numbers, infinite many solutions, or you can write it as negative infinity to infinity, because that is saying the same thing. only in symbols and not words. Okay, so hopefully now you've got some gist of stuff. We've talked about a couple different things, creating a table, dependent and independent. And in this case, you notice every X I chose was an independent number. And then when I plugged it in, it gave me a dependent answer. So you're going to hear it talked about being a input and Y is the output. So if I go back up to my definitions, if you look up here at what I talked about, X value is an input and the Y value is an output, or like I said, an outcome, because when you get done, it has an answer. So that right there is some basics on this. What I want to do is I'm going to stop here because this is just going over terminology, and we are going to pick up and start actually doing some of the problems on page 63 in the next video. I will highly recommend at this point to get graph paper because we're going to be asking you to graph them and determine if they're functions or not. And sometimes if you can't look at the order pairs and tell, it wouldn't hurt to graph them to see how they behave. All right, stopping the video, look for video number 2.